Welcome to Tuesday Lunch and Learn. I'm James Shore. Every week we choose a software engineering topic, come up with a challenge related to that topic, and then solve it live on stream. And this week we're looking at microservice clients. Specifically, we want to make a testable microservice client that can be tested without mocks. If you'd like to follow along with today's episode, GitHub is your place, github.com/jamesshore/livestream. Check out this tag right here, 2020-08-25. Your questions and comments, as always, are welcome right here in the chat, and I will take some of them as we go, and then we might have time at the end for more questions as well. We do have a lot to cover today, so I'm going to get right to it. What we're doing here is we are building a microservice client without mocks. Now, the specific challenge that we're working on is, if you've been watching the show, you know that we've been working on this Route 13 application. And Route 13, of course, is a simple little spoiler hiding mechanism that you see on the internet. Hey, Pellet, welcome. Thanks for joining us. Yes, and I'm happy I could answer the pressing twig-related cover questions. So for those of you who missed last week, I was talking about my new book, The Art of Agile Development, second edition. It is in development right now. And if you go to the back episodes here in jamesshore.com/s/LNL, you can find that episode. Third Man, welcome. Okay, so we've got this, we've been working for this fictitious company, and they're really into the Route 13 encoding. And again, that's the little spoiler hiding mechanism you see on the internet. And they thought that the road to riches, fame and fortune and riches, was building Route 13 as a service. So we built a little microservice for them to do Route 13. But it turns out that did not make them any money. Surprise, surprise. They're well-meaning, but maybe not that bright. So what they've decided to do now is, well, obviously we need to go back to the command line application that we built before, except now it's going to be built with a microservice architecture. And that makes everything better, right? Sure. So our challenge today is we're going to have this Route 13 command line client that's going to talk to our Route 13 service, and so we type in the command line Route 13 whatever, and it's going to go make a call to the service, which is going to do the encoding and then return the result back to us, and we'll display it on the command line. This week, all we're going to do is just the HTTP client part. We need to build a generic HTTP client that can talk to any service. Now, theoretically, we could write just enough to make the Route 13 client work, but there's really not much difference between that and a generic client. And for the purposes of the exercise and the example, I think it's more interesting and more useful to make a generic client. So that's what we're going to do today. Pellet has a great comment. Next week, the microservice didn't make any money, so we'll use blockchain. Yeah, blockchain's even cooler, right? So anyway, that's our challenge today. Is we're going to make a generic HTTP client. This is actually a fair amount of work, which is one of the flaws of the microservice architecture. Is you spend all this time and effort on stuff that's not part of your real value proposition, all this networky stuff. So it's going to be a lot of work. So this is going to happen in a couple of weeks. This week, we're working on the HTTP client. Next week, we'll bring in the Route 13 client. If we have time to finish everything with HTTP client. I wasn't able to finish the entire rehearsal before we started, so I don't know what the timing is going to look like, but hopefully we'll get it all done. Might take a little more than the hour I normally plan for these episodes. Anyway, so we're making a generic HTTP client that can be used to talk to any service, and we're making it so it can be tested without mocks. Now, I've talked about why we want to test without mocks in the past, but very briefly, the thing with mocks, and you can find those past episodes down here, jamesshore.com/s/LNL. The episode you're looking for is, surprise, surprise, testing without mocks. So the reason we want to test without mocks is that although mocks are really good at testing things in isolation, and they're also very good at they allow you to test that you're calling your dependencies in a particular way. What they don't check is that the dependencies work the way you expect that they will. So you end up with little gaps between your units, and that requires you to put in bigger integration tests. And those bigger integration tests are slow and brittle, and they're duplicated effort. So another way to do it is sociable tests. These are tests that actually call their real dependencies, and so when the dependencies don't work the way you expect, your tests fail because your code no longer works the way it is supposed to, because the dependencies don't work the way you think they will. Overlapping sociable tests don't have the problem of requiring brittle integration tests. You don't have to write additional tests. Your unit tests also test the integration with the next level down, but only the next level down. So that's what we're going to do here is we're going to create a linked chain of tests that covers our entire command line application by using sociable tests. And specifically what we're doing today is just that HTTP client part. So how are we going to do this? Some great comments in the chat. Charlie Pancakes, thanks for joining me again. Uncle Scientist, good to see you again. Hopefully it won't be a 24-hour stream, but it might be a little bit longer. So anyway, while you're thinking about how to build the HTTP client, I want to remind you all once again that this show is made possible by the people who hire me for training and consulting. I work with anybody from single teams doing training to multiple teams, all the way up to large numbers of teams that need help with process design and inter-team communication. Because when you have a large number of teams, you often form bottlenecks between teams. So I can help at the team level and also at the large-scale system level, something I enjoy doing all of those. Of course, during the ongoing pandemic, all my work is done remotely, and I do a flipped classroom as well for the training, which is a lot of fun. If you would like to join the fine people who support this show by recommending me to your company, leaders in your company, go ahead and send me an email, jshore@jamesshore.com. Happy to set up a free consultation with you to talk about how it works and how to approach it. You can also find me online, jamesshore.com, and I welcome tweets from anybody at jamesshore. Let me know what's on your mind. All right, let's get back to the challenge. HTTP client, we need to build this. How are we going to do it? Well, it again is what we've covered in past episodes. And if you look at let me go ahead and bring this up here. If you look at the past episodes, and again, this is jamesshore.com/s/LNL will bring you to this lovely page. You'll notice it's a new website, so that's nice, or new design. Testing out without mocks will tell you about how the sociable tests work. Application infrastructure will show you how to build a infrastructure wrapper as we're about to, and then you can find more stuff in these other episodes. Specifically, what we're going to do today is we're going to start out by building that infrastructure wrapper. And again, you can find that in the application infrastructure episode. And then we're going to write focused integration tests around that. So we're going to test that it works for real. And then we are going to make it testable. We're going to make that wrapper nullable by using an embedded stub to disable the network. We're going to support configurable responses, and we're going to add the ability to track requests. So again, if you'd like more information about that, Testing Without Mocks tells you how to do the embedded stubs. It also talks a little bit about configurable responses, I think. If not, then it's also here in robust responses. And then the trackable output you can find in the nullable output and testable logs episodes. So that's the plan. First, we're going to build the infrastructure wrapper. Second, we'll make it testable. There's a lot to do, so let's get right to it. Again, if you'd like to follow along with today's episode, you can download the code from github.com/jamesshore/livestream. Check out the tag 2020-08-25. Once you've done that, you'll need to install Node.js because all the examples here are in Node.js, but everything else is vendored in. You can build the code by typing /build.sh or just build on Windows. Let's go ahead and start that up. And that will lint and test all the code for you. We'll let that go. It's getting a little bit large, but it will run a lot faster for you because you don't have the streaming software running in the background. If you only want to lint and test the things that have changed, use the quick option. And if you'd like it to automatically run the tests when things change, then use the watch command. That will also play a nice little sound when the tests pass or fail. Now, normally, I'd show you how to run the code, and you can run it. You can run the server by running serve and then the port, and that will start the server. And you can run the command line code by typing run the port and then the text to process, but that is not implemented yet, so we're not going to see any examples today of that in use. Okay, so that's how you run the code. Let's get to it. You'll notice, for those of you who've been watching, you'll notice that the directory structure is a little different. We now have multiple projects supported in our mono repo. We've got the Route 13 CLI, which is going to be the command line code. And we've got the Route 13 service, which is our microservice. And then node modules, source/node modules, not to be confused with this node modules. This is our shared library code. So our assert, our ensure, our command line infrastructure, and so forth. This node modules is for third-party library code. This is the library code that we've written. So here in our command line code, we've got the HTTP client and its tests already stubbed in. And this is where we need to actually get to work. So what we're going to do here is we're going to build an infrastructure wrapper that does generic HTTP requests. As usual, we're going to need to test this. We're going to want to test it with focused integration tests. That means that we need to test that the HTTP requests actually work for real when they talk to a real server. But we don't have a real server. So how do we deal with this? Well, actually, we do have a real server, but it's in a different part. It's in a different project, and we don't want to use it. And also, it's not designed for our purposes. We could use a third-party server like WireMock, or Node.js has something called knock, which I think stubs out the request code to talk to a server. But honestly, if you look at those projects, they're really big and complicated. I think we can build our own little spy server, our own little server, to have it tell us what's going on without a whole lot of effort. And so that's what I'm going to do here, partly because I want to show you how it works so you can see it for real rather than us just using other people's code. But also, often when you're using these big third-party libraries, they do all kinds of stuff you don't need, and that actually makes your code harder to understand than it would be to just build the purpose-built thing that you need. So let me go ahead and do this for you here. Now, when I'm building complicated infrastructure, I often like to start out by putting it all in my tests to sort of see that it works, and then I'll factor it from my tests into production. So that's what we're going to do here. We're going to start out by building everything right in the test, and then we're going to factor it over to the HTTP client. Now, the first thing we're going to need is we're going to need a server. So I'm going to say that our server is, well, I'm going to call it a spy server. And this is because this matches the patterns, the language I use in my microservice pattern language, which is called testing without mocks, or not my microservice pattern language, my testing without mocks pattern language. But also because what this server is going to do is it's going to listen for requests and tell us what requests we got. So it's going to spy on the requests. And that way we can test that our requests actually work correctly. So we're going to create a new spy server, and then we're going to start that server. Then we'll do some stuff, and then no matter what happens, whether that succeeds or fails, we are going to stop the server. So this is where we're going to start. Let's make our spy server class. And it's going to need a start async method in it. And that start async is going to actually start the server. To do that, we're going to need to require Node's HTTP library. And then we can say that the server variable is equal to http.createServer. And in stop async, we won't do anything just yet. And that should work. It doesn't actually run the server, but it does work. Now to run the server, to actually start the server, we need to say listen. And we need to pass in a port, which I'm just going to put in as 5001. Now if we do this, this should work. But if we run the code again, it will now fail because that's because we're not stopping the server. So we need to do a couple of things here. You also see it says done called multiple times, so we've got some issues. First, we need to make sure that start async doesn't end until the server is started. So we're going to return a new promise that we won't resolve until the server started. We can do that by listening for the listening event on our server. And once that happens, we'll resolve the promise. So what will happen here is we'll create the server, we'll start listening, some time will pass, the server will start up, and then it will call the listening event. When we hear that listening event, we'll resolve the promise, which will cause this to return back to here and continue on past the await. So that's good, but we also need to be able to stop the server. So down here, we're going to say this.server.close, but we also need this to wait for the close to finish. So we'll return another new promise. And say that once we get the close event, then we'll resolve that promise. So fix this, and this should be this.server. And with luck, fingers crossed, with luck, this will work. So far, so good. Let's put in some console logs. So we'll say starting server, server started, stopping server, and server stopped. Okay, that's all looking good. Now what we need to do is actually make the request. And the way you do that in Node is, again, with http.request, and then you pass in some options. So specifically what we need is a host and a port. And the host actually defaults to localhost, which would work for us, but I think it's nicer to make it explicit like I just did here. So we'll do that. And now we're getting a connection refused. And the reason for this is that request is going to return right away. So what we need to actually do is we need to actually wait for a promise here as well. Otherwise, it will return right away. We'll stop the server, and the server will stop before our request actually has a chance to go through. So make the request. That will give us a request object back, and we'll need to listen for the response before we resolve our promise here. So it started the server, but this promise right here, it never resolved. I can prove that by saying, here we're going to making request. And here we're going to say receiving response. And we'll have to restart our tests because the server never shut down. So we're making the request, and we never get the response back. And that's because we're not listening for the request here, and we're not ever giving a response. So here in our server, we're going to need to say server on request. That will give us a request and a response object. And we can say receiving request. And then we can send the response by saying response.end. And we might have to, I'm not sure if we have to do this or not, we might have to resume the request. Let's see. Yeah, I think we have to resume the request here, because otherwise the stream will be paused. Nope, maybe it's down here. Or, you know what? I think the problem could be that we never end the request. Let me try that. And this is why I put all these console logs and why I do it in the test, because there's always, even though I've done this a million times now, there's always these little things that I forget about. There we go. Starting server, started the server, made the request, received the request, sent the response, received the response, and then we stopped everything. Perfect. So now we've got the whole exchange working. So that's good. Now what we need to do is our real HTTP client is going to need to specify, it's going to need to make specific things in the request. And we're going to need to be able to make assertions about whether or not that has happened. So let's go ahead and do that. Hey, Janelle, I'm not sure how to pronounce your name. Janelle Simprompto. Glad you can make it. Yeah, that is a real screen. Okay, let's see. So we need to be able to make specific types of requests, and we also need to be able to make assertions on it. So let's go ahead and say that the method is going to be post, just for sake of interest. And let's see if we can get the method to show up here. So I'm going to log that our method is request.method. And hopefully that will come up as post. It did. Good. Now let's send specific headers. Let's call this my request header and my request value. And we're going to need to be able to see that over here. There we go. We've got our my request header and my request value. We also have some other stuff that we don't care about, but we'll deal with that later. And then finally, we've got the body. And the body has to actually go here. So we'll send it, and then to listen for it, it's a little more complicated. We've got to say request.onData, and then we'll get potentially multiple chunks of data. So we'll accumulate those into a string. And once we do that, we don't need the request.resume. And then it's not until the request ends that we're all done. So we'll take all of this and put it in the request.end. And then we should be able to log the body like this. Thanks, Genesis says that I'm only one streaming using a light theme. Yeah, dark theme is popular, but I actually find light theme easier to read, so that's what I use. So do we get a body? Yes, right there, my request body. That is good. So now our request is actually working. We're making the request correctly, and we have the ability to, and we've seen that happens. The other thing we need to do is we need to return a response back. But I think we'll get back to that in a moment. Let's go ahead and take this and start cleaning it up so that we can turn it into production code. So we're going to want to be able to specify the host. So I'm going to turn this into I'm going to extract this into a request method. So I'm going to pull out all the pieces that can be controlled. Let's see, the method, pull that out. And the headers, and the body. We'll put all of that up there. And we'll take this and we'll move it outside of our await promise. Now that should still work. Yeah, and it did. So I should now be able to take this whole thing and factor it into a new method, or a new function, which I'm going to call request async. And then we pass in the host port method headers and body. Oh, you know what else we forgot here? We need the path. So let's pass that through as well. And the path let's see if we can see that here. believe that comes in as request.url. There's our path right there. It did not come through correctly, but I think that's because I forgot to put it in the options here. There it is, my path. It's working. Excellent. So now our request async is working, but we're checking it manually. I want to do an actual assertion on it. So let's see. Is there any other things I can do to clean this up? Yeah, I'm going to make this an object so that we can make some of these, I think the headers and body we might want to have be optional parameters in the future. So I'm going to make that an object so we can specify which things are optional and not. But I'm not going to do that just yet. And then now that I've done this, I think I can clean this up by inlining each of these. And I don't know if there's a way in WebStorm to automatically convert a single line to multiple lines. I wish there was, because I do this all the time, but I don't know if there's a quick key for it. I've looked, but I haven't been able to find one. Okay, there's our request. Now what we need is the ability to make an assertion on this. We're making the request, but we're just checking it manually. So to do that, we need our spy server to actually spy on the requests. And the simplest way to do this would be to actually just store the values into a variable. I'm going to say this.lastRequest equals, and then we've got the method, which is the request.method, the path, which is the request.url, the headers, which of course is the request.headers, and the body, which is the body, which we can do as a single line. Pellet says that IntelliJ you can specify when to break lines in the code formatter. Yeah, you can. And I must not have it configured correctly because it will not break lines if they're in single lines, even if it overlaps the end of the line. So there we're storing the last request out, so we should now be able to make an assertion on that last request. I should be able to say assert.deep_equal server.lastRequest, and then say that the method should be post, and the path should be my path, and the headers should be blah, blah, blah. Now I could put this in a variable and compare them directly, but I actually prefer to duplicate and test because I feel like it makes it a little bit more readable. So this almost works. Our body, our method, and our path are working, but the headers don't, and that's because we have all this extra junk in our headers. And also the header values are normalized, so I will need to make a note of that. So let's see, it makes requests. So yeah, we also have this junk, the connection, the content length, and the host. And honestly, I don't think that's relevant for our test, so I'm just going to delete that straight out. So I'm going to take this, and I make a new header. I'm going to copy it, and then I'm going to delete it. Delete headers.connection. Content length. And host. And I think that will now work. Oh, except here, I'll need to use the headers I just created. There we go. Excellent. So now we have a proper test that our HTTP client performs a request. This is great. We also need to have the HTTP client perform a request and returns a response. And this requires a little bit more setup. Before I get to that, though, there is a little issue here, which is that our last request is, well, no, I think I'll come back to that later. So the issue here is that if we do multiple tests, our last request will potentially have the pollution from the previous test, and we don't want that. So we're going to want to reset this after each test. But I'm going to get back to that in just a moment. Before that, though, what I want to do is I want to be able to make an assertion about the response that we get back. And in order to do that, I have to be able to control which response our SPI server sends. So I'm going to say that server.setResponse, and then we'll say that the response should have a specific status, so called 999, a specific headers, which I'm going to say my response header, my response value, and a specific body, which I'm going to just say is my response. Now that set response doesn't exist, but I'll just put it down here, and I'll just store it into a variable, next response. And then here, when we're sending the response, we can set it accordingly. So we'll say response.statusCode equals this.nextResponse.status. And then we should be able to assert, this is the request, we'll assert that the response is equal to status of 999. And let's see if that works. I don't think it will because I don't think we're returning it. Yeah, we're getting an undefined back. So up here, when we get our response, we need to resolve with an object that has a status, which is going to be the response status code. And we'll need to return the results of the promise here. And there we go. So that's the status. Hey, Pellet, thanks for the info about the formatting the objects. I'll definitely check that out after the stream. So now that we've got the status, we can do the headers. So let's assert that our headers should be, again, that's going to normalize the case, I think. Yeah, we're not getting those headers back. So here we'll need to set the headers. Now, you can't just assign the header, an object to the headers. You have to actually call set header. So I'm going to do this in a loop. I'm going to take all of the entries from this next response headers. I'm going to loop over all of them, which will give me a key and a value. And then I'll do response.set header for those key value pairs. And that should get me what I want. So we're not seeing it yet, but I think that's because I'm not returning it here. Okay, that's almost working, except we've got, again, some junk in there. So I'm going to actually copy the response headers, and then we'll delete the ones we don't care about. There we go. And lastly, we have the body. So we're going to set the response to my body, and then here, when we end our response, we just say that we want to pass the body through. Now here in our assert, we're going to need to assert that the body is equal to my response. We're not getting it yet, but here in a request, we can send it back through. But we need to listen for it, just like we did in the SPI server. So we'll say response.on data. We'll get a chunk. We'll accumulate that into a body. And we'll default it to being nothing. Okay. that did not quite work, and I had expected it would. We're getting nothing, but we expected my response. So I presume that means that we're not sending it back properly in our spy server. Or maybe, yeah, we're setting the response. There's the body. Let's see what we got here. So we're definitely sending the right body, but somehow we're not getting it, and I'm not sure why not. Oh, I know why. Because we're resolving before we receive the body. We also need to say response.onEnd and not actually resolve our promise until we've gotten all of the response back. And there we go. Excellent. So we're in pretty good shape now. I think now we can take this and we can actually migrate it into our production code. So I'm going to take this code here and I'm going to put it inside of our HTTP client. So here, instead of saying request async, I'm going to say give me a client. And that's going to be HttpClient.create, because in Node.js, I like to use factory methods rather than usually using normal constructors. And the reason is there's no constructor overloading, there's no private constructors, so it's just easier to use factory methods. Now we don't have an HTTP client, so I'm going to need to import it. And we need to, okay, we don't have a create, so I'll go ahead and create it. And then I can have this client use a request async. Now that's going to fail. We don't have a request async, but I can just take this code and move it over here. Looks like we need the HTTP library. There we go. Excellent. Now that we have everything working, or working well enough and figured out, I can take out all these console logs. And just generally clean things up. And one of the ways I want to clean things up is by doing some runtime type checking. So I'll say that we're going to have a signature with a single parameter that has an object, which is going to have a host, which will be a string, port, which will be a number, method, which will be a string, path, which will be a string, headers, which will be an object, and body, which will be a string. This ensure.signature, this is a little runtime type checker that I wrote. It's not on NPM or anything like that, but you can find it in the source under util. It's ensure and type if you wanted to borrow it. It's all licensed under MIT. I don't provide support for it. So there's that. Let's look at this. Any other way we can clean this up? No, that's actually looking pretty good, I think. How about over here? Well, I'd say the big thing here is that we've got this try finally. The next thing I want to do is I'm going to want to write another test. I want to say that the headers and bodies are optional. But before I can do that, I've got this creation of the spy server and this try finally, and it's really ugly and it sort of makes things hard to understand. So what I want to do is I'm going to take this and I'm going to factor it out into a before and after. Now, I generally don't use before each and after each in my test because I feel like it makes the test harder to understand. But in this case, the spy server is it's just scaffolding to make everything else work. So I think it's okay in this case. I think it will make the code easier to deal with. So before the tests run, I'm going to start the spy server, and then after it runs, I'm going to stop it. I'm going to do that before all the tests and after all the tests, rather than before each one. And the reason is that it takes a little bit of time to start and stop the server, and I think it'll be faster and more convenient to just do it once. Pellet says, am I hallucinating, or does a good chunk of this code resemble the HTTP server you wrote earlier? Yeah, it resembles the HTTP server quite closely, Pellet. The difference is that it's got the spy capability that the server didn't. Like I said, we could have used a generic server. We could have used the server we wrote. We could have used WireMock or something like that. But I think it's a little bit simpler and easier to understand this code if we've got a purpose-built spy server. The other thing is since we're writing this HTTP client to be testable, we're only going to use this spy server once right here. Nothing else is going to use it. So another reason to just keep it specific and rather than generic. So here I'm going to say that the server is equal to a new spy server, and then it will await server.startAsync. And then after they're all done, we'll stop it. If I do that, I should be able to get rid of this try finally. Make this code a little bit easier to understand. Now, it's still a big, complicated test, and I don't love that it's big and complicated, and I could have split it out into a performs request and a returns response piece, but I actually think it's just a little bit easier to deal with like this. Now, the other thing I want to do is, now that we're implementing multiple tests, I do want to reset the spy server before each test, so we don't have any cases of the second test getting results from the first test. Now, to reset it, what I need to do is I need to have the last request set back to null, saying we didn't get one, and the next response will default to some value. So let's say the status is 500, the headers are empty, and the body is spy server response not specified. And let's also reset it on construction. Okay, now we can write the next test, which is that it doesn't require headers and body. Or let's say headers and body are optional. So for this, we're going to need the HTTP client. We'll make the request, but we don't care about the response in this case. The host is unchanged, the port's unchanged, the method we don't actually care about, but I'm going to change it just for interests. My get path, and I won't put any headers. And then we can assert that the server's last request is equal to a method of get path of my new path. Headers should be blank, and the body should be blank. And that is going to fail because our type checker is saying that they must be defined. But we can just go up here and say that the headers can be undefined or an object, and the body can be undefined or a string. Okay, there we go. That is our generic HTTP client, I think. We've got the infrastructure wrapper, we've got the ability to make a request, and we've tested that it actually can talk to a real server for real. We're not done yet, but this is the first step. So I'm going to go ahead and check this in. What we've done is we've added the HTTP client. So you may recall the first thing we're going to do is build the infrastructure wrapper, which we've done. We've created the dedicated wrapper, and we've written the focused integration tests. Now what we need to do is make it testable. And we might just get this in under the wire. It's like I said, it's a little bit long today. What we want to do is we want to make this nullable by using an embedded stub. We'll support configurable responses, and we'll add the ability to track requests. So let's get to that. First thing we want to do is make it nullable. This means that when you actually use it, it doesn't make requests to the network. That's how we can have sociable tests that are still fast. So let's go ahead and set that up here. As usual, I like to call this nullability. We'll say that it doesn't talk to network. And then to implement this, we can say, give me a client, but this time, give me the null client. That, of course, is going to fail because we don't have a create null. But I'm going to implement it, and for now, I'll just return a normal HTTP client. And then we can make an arbitrary request. It actually doesn't matter which one we make. So I'll say that that doesn't matter. And then we'll assert that the server's last request is null. So we should not have seen a request. But of course, let's see, that needs to be request async. But of course, because we're using the normal HTTP client, it is going to work. It is going to make the request. So the test is going to fail. So as usual, the way we're going to implement this is with an embedded stub. To set this up, I'm going to go ahead and comment out this test for the moment. And in our create, we're going to pass through. Actually, let me just skip this entire test. Rather than using the HTTP library directly, we're going to inject it and store it into a variable. And then anywhere that we use it, we'll use our injected variable. And what this does is this gives us the ability to control how the HTTP library works. So now in our test, we will pass through a new null HTTP object instead of the real HTTP. This is the embedded stub pattern. And again, you can find more about this jamesshore.com/s/LNL for lunch and learn, and look for the testing without mocks episode. It'll explain how this works. But I'll show you as well. So we're going to pass in the null HTTP. Of course, we'll need to create it. And the whole point of the null HTTP is to have the same interface as the real HTTP, but to not do anything. So we'll just start out by making a null HTTP that literally doesn't do anything. This is going to fail though, because there are some methods on HTTP that we're using. Specifically, right here, http.request returns a request object. Now we don't need to do anything with that, but we do need to not fail. So I'll implement the request method, and I'll have that return a new null request object. Now that's going to fail as well because we call request.end and we call request.on. So let's watch that fail. So request.end is not a function. I'll just add it. And request.on is not a function. That's actually part of the standard event emitter library that comes with Node, so I'm just going to use that. Okay, now it's hanging because we don't resolve our promise until way down here inside the response. So we're going to need to get this response event in order to run into this part of the code. So down here in our request body, I'm going to emit the response event, and I'll pass in a new null response. Now notice that as I'm implementing this embedded stub, I'm not really thinking about how does the real thing work. I'm just thinking, what does my code do? How does my code use the real code? And how can I do just the bare minimum in order to allow that code to finish? So now that I've created this response, it's going to, when end is called, it's going to emit the response event, and that should run through into here. And that will call response.resume, which I don't think we actually need anymore. So I'm going to take that out. And then it's still going to hang because it's going to get down here to the response.onData, response.onEnd. That's not going to happen. So let's see. And I'm actually not sure if this emit is happening either. Let's see if it is. Make a constructor. All right, let's just see if this shows up. Yeah, it is emitting, it is getting the, it's running the new null response, but I don't know that it's ever doing the request.on because I think we're calling emit inside of end before this event listener is set up. So I think what we need to do is put this in on rather than end. But let's see what happens. Let's see. Are we ever getting the response through? No, we're never seeing that response. So I think what we need to do is, I think I'll just put the request.end after the request.on because I think that's a little cleaner anyway. Okay, there we go. Now it's saying response.on is not a function, and that's because it's calling this right here. We'll make this extend the event emitter. And we don't need this anymore. There we go. It's running our response code. And now it's still pausing because we're never getting to this resolve, which requires us to emit the end event. So let's do that. Let's say that in our constructor, we might, oh, you know why this didn't work before? Is whenever we emit an event, what we should really do is put it in a set immediate. And that way it doesn't run right away. And this will resolve all kinds of little issues like the ones we just saw. So let's do it that way. We'll set this into a set immediate. And here in our constructor, we can also emit, we can set immediate and have this emit the end event. And we'll need to call our super class constructor. Need a semicolon here and a semicolon here. Now, what have I done wrong here? I've gotten myself confused. Let me back this up. I took too big of a step. Said it might take more than an hour, and I think that's the way it's turning out. Okay, so we've got this timing out, and that's because we're not getting the end event. In order to trigger the end event, we need to have something do that. And I think we can do that in our constructor when we create the null response. But we'll have to do that in a setImmediate block so it doesn't happen right away. And then we should be able to say this.emit end. There we go. I'm not sure why it didn't work before. I think it's because of the way I did this here. So I also want to put this into a setImmediate. Oh, I see what the issue is. Yeah, this needs to be, the setImmediate needed to be on the outside. There we go. So now we have our HTTP client, our null HTTP client, using the null HTTP library that we've created, which is just a really simple embedded stub. And we're just building the bare minimum necessary to get this code to work. So when a request method calls, we create a null request. And then we set that up so that it's going to emit a response when the end method is called. So we say request.end, then we emit the response. That gives us a null response. Then when and then we set that up to just end right away, which will cause this code to resolve. Again, you want to build your embedded stubs for exactly the code that you have, which is why we put them in the same class. Because this isn't a generic stub, this isn't a generic fake. It is just barely what's needed to get our code to work, and just the code we have. So let's make sure I didn't break anything else. Okay, we're all good. So not only does it need to not talk to the network, it also needs to be configurable. We need to be able to say that when we're testing our code, we need to be able to say, well, this is how the remote server responded. And this is a little complicated. So what we're going to say is that it provides a default response. We'll do that to begin with. So we'll create a null client. And we'll get a response from that. And honestly, the request doesn't matter here. So I'm just going to hard code this as an irrelevant request. I'm going to take this and factor that out into a variable. Okay, so far so good. And now what we want to do is we want to assert that by default, the response that we get from our null request is going to be what? Well, I'm going to say that it's going to be a status of 500, no headers, and a body of null HTTP client default response. And actually, let's say 503 because I believe 503 is not implemented. Okay, obviously we didn't get that. We got an empty body. We did get no headers, but our status is undefined. Actually, let's say that the headers, let's give us a header as well. So we'll say this is null HTTP client default header. Okay, so now obviously we need to support all of this. Now where this comes from is response.statuscode, response.headers, and the body comes from the data. So let's take these one at a time. The status will be easy. We'll just have our null response implement a get status code that returns 503. And now we can see that the 503 is coming through properly. Next, we want the headers. And again, I think that's pretty easy. Our headers come from response.headers. So we'll just hard code that. And then the body. And the body is a little bit tricky because that's got to come from a data event. But what we can do is we can emit it just like we emit the end event. We can say emit data, and then the body, which is null HttpClient default response. There we go. But we also need the ability to configure these responses. And this is where it gets a little bit trickier, because the HTTP client, the way services work is they can get really complicated and they can require multiple calls and multiple endpoints before you really get anything useful from a business logic perspective. So we need our null client to actually support that complexity. And I think this is one of the areas in which I'm not sure that the nullable infrastructure wrapper pattern is actually the best approach. Maybe MOX would be better here, but I'm going to show you how it works. So our null client needs to be able to provide configures responses, or can provide configured responses, and that actually needs to provide multiple responses for multiple endpoints. And those are multiple configured responses. And setting this up, like I said, gets a little bit ugly. So we're going to say that our responses are endpoint 1, which will be an array of responses. So let's go with status 200, headers my header, my value, and the body of my body. But we'll also want to get a separate, we want to be able to do multiple responses. So I'm going to say that we've got a separate response, which is 404, and that's going to have no headers and no body. But we also want to support multiple endpoints. So for this one, I'll do a status of 301 and a body of endpoint 2 body. Now, arguably, this would be better off doing this in multiple tests. Not sure how I feel about that, but I do think that this test is a little bit big and complicated. So we'll do this, and then what we need to do is we make the requests. So response 1A is going to be client.request async. We do care about the path, so let's say that it's going to be host port method. We don't really care about the method, but we do care about the endpoint, which is endpoint 1. And then we'll do that again, and then we'll do it again. And we should be able to assert that each of these is what we expect. So response 1A should equal status of 200, headers of my header, my value, and a body of endpoint 1 body. Now let's just take this a little bit slower. So I'm going to slow this down and do one piece at a time. So first off, we want to get the right status out of this. But we're not. We're getting all of this stuff. So let's go back into here. In our create null, we're going to specify the responses, and we're going to pass that through to our embedded stub. That's the way we normally do configurable responses. In our embedded stub, we can store those off. Actually, that needs to go in the constructor. So far, so good. We're not using it yet, though. Line 16. I must have spelled something wrong. Yeah. Now, when we get a request in, when the request is made, we're passed in a path. So at that point, we can say that the response that we're going to use is actually this.responses with that specific, for that specific path. And that will select the element of the object that we're using. So we're creating an object with all these different paths as key values, and then the responses we want as arrays. So given a particular path, we'll select the response we want out of that path, out of that object. So that means that down here in null request, we're going to get a specific set of endpoint responses. And we can store those off. Now again, this isn't going to work yet. Now we can pass that. When we make the response, what we can do is we can take our endpoint responses and we can actually shift off the last one. Now, what if there are no endpoint responses? Well, normally I'd test for this, but we're a little short on time. So what I'm going to do is I'm just going to put it in. If there are no endpoint responses, we want this to default to an empty array so that we don't get an exception when it tries to shift off something that doesn't exist. So down here in our constructor, we'll get a response. And again, we can save that off. And now finally here, we can return the response, this.response.status. Now, what if the status doesn't exist? Well, let's just see what happens here. Okay, so we got the right status here, but now we've got some issues with not being able to read things that don't exist. So let's see. Up here in responses, we're going to default this to an empty array, empty object. Now it can't read status of undefined down here. So what we need to do is we need to provide a default. So let's do this. Let's say that we're going to get a status, and we'll default that whole thing to a status of 503, headers of whatever it's supposed to be. This. And a body of null HttpClient default response. So if we don't get any response at all, we'll use the default response. Then we can save the status rather than the response. We'll do it this way. And I think, fingers crossed, I think that will work. And it does. We've got the status, we just don't have the body and the headers yet, but that is easily fixed. So now we're going to put in the headers. That's going to give us the wrong value. We expected my header, my value, but we got null HTTP client and default header. So back here, we'll pull the headers out of our object. And we'll save them off. And we'll return them here. Twitchloft says, I imagine unit testing in JavaScript is even more useful than language like C# and Java, since you can do so much weird stuff in JavaScript. Yeah, you're absolutely right, Twitchloft. It is practically required in JavaScript, in my opinion, because JavaScript can be so weird. That said, using a good linter makes JavaScript really not that much different than programming in other languages. And then if you add on to that the static type checking that I do, or the dynamic runtime type checking that I do, then it's actually quite easy to program in JavaScript, in my opinion. The main thing that I end up using my test for is not for the type checking, which some people write tests for, but more for the logic, like you're seeing here. Okay, so we've got the headers working. That's good. Now we just need to get the body through, and then we'll be good. So we've got our endpoint 1 body. That's going to fail. It's expecting endpoint 1 body, but it got it under null. So we'll pull that out here. And we don't need to save it off in this case because we're going to use it right here. And there we go. That is working. So again, what we're doing is we're setting up our responses as an object with a key for each endpoint and then an array of values to return from that endpoint. We're passing them through. When we create our null HTTP client, we pass them through to our null HTTP embedded stub. Our null HTTP embedded stub saves them. And then when a request comes in, we pull off the specific array that corresponds to the endpoint that we've been asked for. That request saves off those endpoint responses. And then when it's time to emit a response, it shifts the first one off the front. So we should now see that response 1b is equal to a status of 404, headers of nothing, and a body of nothing. And I think the status will work, but I'm not sure about the headers and body. I think they'll be undefined. Yeah, the body is undefined. The headers came out just fine. So what we need to do is we need to have the headers here default to an empty object and the body default to an empty string. And we expected an empty object. I must have specified that wrong. I did. There we go. And then finally, our second response for the other endpoint is going to equal a status of 301 and a body of endpoint 2 body. And the headers are going to be empty. And there you have it. That is our configurable responses for the HTTP client. Like I said, it gets a little bit ugly, and I'm not sure if I really like it, but it's that's how it works. And it does turn out that when you're using it, as opposed to programming it, it's pretty clean, as you'll see next week. Uncle Scientist says, can you remove response between, oh yeah, can I remove response 2? So Uncle Scientist says, can I remove response 2 between response 1 and 1A and 1B in order to make sure that, it's not just working by coincidence, I presume. And we can see that it does. Uncle Scientist says the asserts, the asserts shouldn't matter, but I'm happy to move it. because at this point we've already gotten the data and it shouldn't be changing. There we go. Viable Clan member says, what do you recommend for testing an Open API v3 YAML? I have no idea, Viable Clan member. I've never tried that. That's an interesting question. Okay, so we've got, this one is going really long. I apologize for that. We're almost done though. We've got our embedded stub. We've got our configurable responses. Now we just need the ability to track requests. And this we've done before. Let me just check in what I've got so far. We've made HttpClient nullable. Now what we need to do is we're going to have the generic ability for anybody to track the requests that are made on the client. So we perform requests, return response. The headers and bodies are optional, and it tracks requests. So we'll make a client. I'm going to make a null client just because I can. It shouldn't matter though. And I'm going to make a request. And I'll make that request to our host, our port. Method, I think I'll use post. And the path, it's going to be my path. And the headers will be my header and my value. And we're going to want to track this just as we saw in previous episodes. And again, if you want to see how this works, look at, if you want the details of this, look at the nullable output. The nullable output episode explains how this works. But I've taken that code and I've abstracted it into a generic function, so we're just going to use that. So we're going to say the request is client.trackRequests, and that will give us an array into requests that has every request that we make. And then we can assert that requests is equal to a single object that has host of host, port of port, method of post, and we're going to want to make that case insensitive, and headers of my header, my value. Now, normally I would make this case insensitive as well. And actually, I think I will because that's just better. I was thinking maybe I won't because we're running long today, but I think I'd like to get it proper. And that is going to fail because track request doesn't exist. But implementing it's pretty easy. I'm going to use our infrastructure helper. And we're going to need to make a event emitter. And a request event. And then our track requests method is just going to return the result of calling our infrastructure helper, track output, and that takes the emitter and the request event. And what this will do is this will set up our return object so that we don't actually store any of the requests until we start tracking them, and then it uses the events to deal with it. Now, by default, this is going to not do anything because we're not actually emitting what we need to. But here, when we make the request, we will go ahead and emit that event. And that, of course, will have our host, our port, our method, our path, and our headers. Now, that's not entirely going to work because we aren't doing the normalization yet. So the method needs to be too lowercase. Hopefully I did that right. Oh, like that. And our headers needs to be normalized headers. And to normalize the headers, we've done this before, but I'm going to do it again. We'll take all of our entries. Actually, you know what? We're running short on time, so I'm going to do this off camera. For now, I'll just keep this as is, because this is not super important for us right now. So that should now work. And there we go. That is actually everything. We have, what we've done here is we've built a testable HTTP client. We've done that by building the infrastructure wrapper. We created a dedicated wrapper for our HTTP requests, and we wrote focused integration tests for it. So you can see here, our focused integration tests are checking that we're actually talking to a real server. The way we did that was we built a little spy server. You can see the spy server is actually just a couple dozen lines of code. It's pretty easy to write and doesn't require the reader to go interpret a big complicated library. But you could, of course, use something like Knock for Node.js or WireMock. And then the other thing we did was we made it testable. We used an embedded stub to disable the network. We supported configurable responses, and we added the ability to track requests. So again, looking at that, we can see the null uses the embedded stub here. This is one of the more complicated embedded stubs we've made, but this is about as complicated as they get. We pass in the response, pass that all the way through, and then use that with some clever destructuring to get the values we want, and then we emit those values back out here. And then the actual production code is exactly the same whether you're using the real HTTP library or the embedded stub, which means that when we test our code that uses the null, we're actually running the same code paths. So we have a sociable test that will fail if we do something to change this code that would cause the caller to break. And that's really important. So that, again, is microservice clients without mocks. That is the very first part. Next time, what we're going to do is the Route 13 client. We'll write a high-level piece of infrastructure that uses this lower-level piece of infrastructure. It's been a long session, so I'm not going to take any additional questions or comments. Just want to remind you that next week's session is going to be on September 1st, and we are going to do part 2 of that microservice clients without mocks. And I also want to remind you that if you liked what you saw today, you'd like me to bring it to your teams at your company. Whenever I do a private session, it's always in your programming language using the frameworks and stuff that you care about. For example, the OpenAPI v3 is something that I could do for you in a private session. Thanks very much for watching, everybody. I'm going to make that final normalizing the headers change, put that in, and then I'll upload the code, and I'll put that up in the comments. For those of you watching the recording, the tag is going to be right here, 2020-08-25-end is how you can get the finished code. Thanks very much, everybody. I will see you all next time.